Welcome. We're delighted to see you. I'm going to jump right in here without many preliminaries then and introduce our first speakers, Nick Pallotta from the National Agricultural Statistics Service and Adel Alaeddini, who's from the School of Data Science at the University of Texas at San Antonio. And they will be talking about discovering data sets in unstructured corpora. And so, Nick, I will turn it over to you.
All right, thank you so much, Nancy. First of all, I want to thank the Harvard Data Science Review team. It was an incredible team to work with to get this paper published. So very excited about working with them again in the future. As Nancy said, our title is Discovering Data Sets in Unstructured Corpora. The key word there is unstructured. That's what sets our presentation out a little bit from some of the other things that you may hear about today. So we'll focus on that unstructured corpora word. Also want to thank my team. Here you see on the screen, Mark Locklear, Zhengyu Ren, Victor Robilla, and then, of course, Adel Alaeddini, who will present on this a little bit later today. All right, so I work for the National Agricultural Statistics Service, NASS for short, and we put out over 400 reports on the ag sector on things related to crops, livestock, environmental statistics, economic data, all kinds of things related to agriculture. Our mission statement is timely, accurate, and useful statistics in service to agriculture. A key word there being useful. That's really what got us started working with this democratizing data team, thinking about how we could portray a measure of usefulness of our data and tie it back to our mission statement, which was really important for us to do. So what we did in working with that team, the democratizing data team, is use their large language model, their AI model, to scan the corpus of research publications, looking for our data set usages in the body of research articles. That's kind of the whole theme of this presentation, using AI to discover data usages in the body of articles. And so we did that and put together this dashboard that you see here on the right. And the peer-reviewed research journal articles have some additional utility because those articles are tagged with things like topics, with things like who's publishing, who's using the data, where are they at when they publish this data. So you can see those elements here on the dashboard. Bottom left shows some topics. There's a map there showing where our data is being used. And so there's some really great utility coming out of that product. For NASS, though, really our added value proposition is that most of our statistical products are developed by producer survey. So we send out surveys, we collect it, aggregate the data, and we publish it as official statistics. But a research team that we chartered several years ago found that many producers don't really see the benefit of responding to our surveys and thus don't respond. And I can't blame them, right? We all get surveys in the mail. We don't really see why those surveys would benefit us from spending our time on. So the thinking was, well, hey, we've got this dashboard that shows usages of it. Shows the topics. Let's put it in front of them at the time of the survey and see if that has an impact on response rates. Fast forward, it did, but a non-statistically significant increase. So we really couldn't tell that the dashboard had really an increase in response rates. I wanted to go through this diagram a little bit to show a little bit of the dynamic that's happening with testing the dashboard against producer responses to surveys. And I'm going to fill in this circle here with some additional boxes, but I want to start with box 5 and 1 to try and highlight the symbiotic relationship of producers recognizing the value of our data product, which is box number 5 here, caring enough to then contribute their time to complete the survey. So this is kind of going to come full circle for them, or at least that's the objective, to show them that it does come full circle for them and the data is useful to them. But we release our data onto our website. It's really not clear that producers are going to our website and looking at the data and finding it useful and then responding. So that's really not the correct path. The current approach that I just laid out is our data sets used in research put on that dashboard. Hey, let's see if data used in research moves the needle on response rates. And I just mentioned that it didn't. So logically thinking, well, how close can we get to something the producer cares about that will trigger a response to our surveys. And the thinking for this use case was, well, there's a great service called the Extension Service that translates research into actionable advice that farmers can use to help improve their farming operation. So it was thought that if we could find our data set usages in these products, that might move the needle a little bit more than the research article. And so that's kind of the premise of what we did in this paper. Just a little bit about Extension Service. I pulled this from their website. Extension provides non-formal education and learning activities to farmers and other residents of rural communities and urban areas, taking knowledge gained through research and education and bringing it directly to the people to create positive change. So really a research translation service for a usable product for the farmers, exactly what we were looking for. However, the Extension Service is decentralized. It's spread across the more than 100 land-grant universities across the United States, and each of them maintain their own websites, have their own hierarchy, and have their own processes. So it's a decentralized system and unstructured, as we talked about at the beginning. However, there is a search service existing called Search Extension. There's a little bit hard to see image here at the bottom right, but that's an image of the search service enhanced by Google that searches across 158 URLs that make up the Extension Service. And these URLs would be the unstructured corpora that we would use to target our research at. All right, so now we've got our unstructured corpora, the 158 URLs. What are we going to look for? Well, we identified 22 reports that were of high interest to the agency to look into those URLs to see if we could find them using those data products. And many of those 22 reports go by aliases, right? The first line here is Census of Agriculture. Well, they could have referred to it as the agricultural census in the article. So there's many aliases that kind of accompany a specific report name. They go by a frequency can be included in the second line here. You see cattle. It could also be called the January cattle if they're referencing a certain month of the publication. And the report names are very generic. The report name for cattle is called cattle, not even cattle report. It's just called cattle. So that was a challenge as well. And then we don't have digital object identifiers yet. So to put those two concepts together, this diagram helps show how they intersect. We've got the 158 URLs on the left-hand side of this diagram. If you think about a website, it's got a hierarchy. If you click on the link on the main site, we would call that second level or one level down from the root. You navigate, drill down in one level of the site. But sites can have many different levels. The 22 official publications, including their aliases, balloon to 233 aliases. So just looking one level down at the extension corpus for 233 official publications resulted in nearly 2 million possible citation opportunities to look for. So quite a lot of volume, just one level down from the root site of extension sites. So that was one approach. One more, and then I'm going to turn it over to Adel, was we were able to get a hold of some JSON files, which are machine readable. This was from a great effort coming from the Extension Foundation team, Mark Locklear, co-author of this paper, and Dr. David Warren out at Oklahoma State University. They're creating something called Extension Bot, which is a bot, a large language model bot that is fed by the work of the extension. And so there were 2 universities that had signed up for that program at the time. Their content was converted to JSON files to feed that bot, and those were provided to us for this experiment. Now I'm going to turn it over to Dr. Alaeddini here to take us through a little bit of the methodology that we use to look for our data set usages in those publications.
Thank you, Nick.
Yep.
Hi, everyone. One of the objectives of our methodology was to identify data sets using machine learning methods, as you heard about that. A key approach involved recognizing if strings within articles refer to data sets, surveys, or reports. For example, on the right-hand side of the slide, the term ADHD is identified as a dataset despite the absence of related links or references. To automate and machine learn this process, we utilized a transformer-based heuristics inspired by a previous Kaggle competition. The model was further enhanced with Shorthart's algorithm to identify line name patterns and aliases of in the data sets. As a result, the model identified 15 data sets from over 3,000 Oregon State articles, with 6 of them related to the Census of Agriculture or ARMS. In addition to that, it identified 20 data sets from 1,500 Oklahoma State articles, with 3 of them related to the Census of Agriculture or ARMS. Now, this was by looking at the strings. Beyond identifying data set related to the strings, we employed an algorithmic web scraper to analyze hyperlinks from Oregon State and Oklahoma State University. For the case of Oregon State, the scraper searched over 90,000 sublinks and the first level down, resulting in 14 links to the data assets. For the Oklahoma State, similarly, scraping over 70,000 sublinks led to identification of 8 links to NAS Quick Stats and 3 to rural-urban continuum code datasets. So this result suggests a relatively weak referral to datasets within the articles. Next slide, please. To gain further insight, we conduct a bag of word text analysis using what's so-called latent Dirichlet allocation model. The objective was to identify the main topics covered in Oregon State University and Oklahoma State University articles as illustrated below. For better understanding and better illustration, we limit the number of topics to 20 and the number of words to 10 per topic. So such information can be used to analyze the similarity between extension services, their articles, and USDA reports.
Adele, just so you know, you've got about 1 minute left.
Yeah. Observing a few discoveries of data assets within the articles, we took a step toward identifying missed citation opportunities. For that purpose, we developed a simple classifier to compare the similarity between the content of USDA official reports and extension services. The classifier used a bag of words with 35 most frequent words as inputs and the label of the 22 USDA official reports as the output. After training, the model achieved over 90% accuracy, and it was then used to identify missed opportunities in a sample of approximately 100 articles, maintaining same level of accuracy upon human verification. This model can assist identifying the most relevant official reports for citations in extension reports and web context. So with that, I'm going to hand it over to Nick for the final thoughts and remarks.
This is our last slide, Nancy. So to summarize what you just heard from Adele, there was a lot of work done there and really returned not enough volume to make it a scalable endeavor. We're looking to feed a dashboard with things that may move the needle on response rates, which would be a real value proposition for the platform, a real impact deciding usage of the dashboard. However, there just wasn't enough there. But it was an eye-opening experience. We decided to do some meetings with extension service content creators to find out what types of documents they were putting out, what the propensity of them citing NAS data in those types of documents was, and try to figure out how we can reduce the burden on them having to cite our data. We were putting all the burden on them to properly cite our data and didn't really provide any assistive tools like DOIs or citation import capabilities. And the last point I'll make here is, we'll attempt this experiment again, but we really need either a larger corpus of machine readable files, which will help us point the models at, the AI at, way more efficiently than all the web scraping that we did, or potentially a centralized extension corpus, something where these articles of extension are being curated and are putting in some kind of structured corpora. That would help immensely, and we look forward to those becoming enablers for our project. Thank you, Nancy.